Okay, we're going to do multiple try catches this time. I'm going to use the same example I used for the last video. So with the last video, I was reading it from a file. So I'm just going to grab that so that's a little bit less confusing. So I only have one method here. And let's put this in here. Okay, so as just a let's see, try catch, or try multiple catch. Multiple catch example. Alright, and I'll save that. Alright. Good. And we'll run that. That should throw an exception. So this is execute before the exception happened, and then here's the where the actual exception occurred. And so it went down to the catch, and then we did afterwards. So we don't need throws anymore. Let's have another exception happen in here. Let's have ourselves a very simple example. Let's call it 1D equals 1, 2, 3. And then what we'll do is we'll try and access 1D. Now, I've had a previous video where it makes more sense to use an if statement. But let's use this. We'll say 1D 200, just some number, equals 200. Now that will cause an exception to be thrown, but it's not a file not found exception. So I can try that, and I'll run it, and we have an array index out of bounds exception. Aha! So what we can do is, even though we have a scanner here that throws the file not found exception, this calls the catch the array index out of bounds exception. And I'll say system out println array occurred. There we go. So when we run this, compiles, we have the before exception that was printed out, then this caused an exception, and then the went to this catch. Notice we have multiple catches. We have the array index out of bounds exception, we have the file not found exception, and then after it ran this, it kept going after the try catch. So understand that anywhere in the where the first exception handles, or anywhere where the first exception occurs is where it'll spit it out of the try and go to the corresponding catch. Well, there's all sorts of things. Let's see here. Let's get something from the input. Scanner keyboard equals new scanner, and I'll say system.in. So what if I do, let's not put it there, let's have it before exception, and then we'll say int I equals keyboard.next int. Well, what happens if I give that a string? Okay, we're going to compile it, we'll run it, it's waiting for some input, and I'll just put some letters in there, and it died because it's an input mismatch exception. Well, we can have as many catches as we want. We can have the array index out of bounds exception, and file not found exception, the input mismatch exception. There's also the catch all exception, the exception. And in this case, what we're going to have is system out println something bad happened, but since exception is so generic, I do not know what. So the exception is anything else will have happened. In this case, if we do the input mismatch, well, input mismatch is not an array, index out of bounds, so it doesn't match there. It's not a file not found exception, so it doesn't match there, but it will match here. Any exception will match with exception. So if we run this, we'll put some gibberish in there. It says something bad happened, but since exception is so generic, I do not know what. All right, it called this one. Now the order matters here. So if I were to move exception up here in front of array index out of bounds, then everything will match to exception. The array index out of bounds will match to exception. File not found will match to exception. In fact, it'll compile and say, hey, you know what? Exception array and out of bounds has already been caught, and so has file not found. So we have to make sure that the most generic ones are found at the very bottom. If we go to the API, so let's go to Java 8 file not found exception, and we go to there. If we look at the inheritance list, which we'll look at possibly at a different time, we will find that file not found exception inherits from the IO exception, which inherits from the exception. So the way it works with the order, whether you understand inheritance or not, doesn't really matter, is that if you put IO exception before file not found exception, then this one will never be caught, never be used. IO exception needs to be after file not found exception, and exception needs to be found after. So this is the order, actually the reverse order in which we need to put our exceptions. We can look at the array index out of bound exception as an example. So Java 8, and if you look at here, this one has to be before the index out of bounds exception, which has to be before runtime exception, which has to be before exception. So the order of these matters. If anything, if array index out of bounds exception inherits from anything above it, then it would never be caught. So you can have as many catches as you want, and it's just not a very good idea. How big should your try be? Usually the size of a try should be just one idea. You don't want to put your whole program into a try catch. You just want to put one thing that might cause the exception to the try catch. Makes your code bigger, but it makes it easier to understand. So in review, the try catch is used to catch exceptions instead of crashing the program. And the catches, you can have as many as you want, but they have to be in the order of inheritance. And so the exception is it'll catch everything, so we don't have to worry about that, but that should be last. But it's the least specific. We don't know exactly what happened if this is called. On the other hand, we want to be specific so that we know exactly what happened here.